Bismillahirrahmanirrahim. In this lecture, we will discuss our experiment number 2, which is how to perform plane turning operation on CNC lathe using CNC simulator software. Like previous lecture, before doing practical work, here again we will first check our design code with the help of simulator software for any error. So let's start with the experiment. Turning is a machining process used to make cylindrical parts in which the cutting tool moves in a linear fashion while the workpiece rotates. Generally, in turning, it reduces the diameter of the workpiece to a specified dimension and produces a smooth part finish. For every lathe operation, care should be taken that a cutting tool or parting tool which we are using should be harder than the material of the workpiece, so that it can be able to cut the workpiece into the desired shape. For every mechanical operation on lathe machine, for good finish, we will use two type of cut. The one is roughing cut and the second one is finishing cut. The objective of rough cut is to remove bulk amount of excess material from the workpiece in every pass. This can be done with the high feed rate and with more depth of the cut size. In this case, the material removed rate will be high, but the surface roughness will be very rough or poor. An old cutter can be utilized for the roughing purposes. After roughing cut is the finishing cut. The objective of finishing cut is to improve surface finish, dimensional accuracy and tolerance. This can be done by using very low feed rate, and the material remove rate in this cut is very low, but surface roughness will be good and the surface finish is also with accurate. It can provide high dimension accuracy and close tolerance. For this purpose, choose sharp cutter and with a good finish tip. In here I have repeated some slides. The last one was from the introduction lecture of machine shop, in which turning was discussed in detail with tool and types of cut. Now this is our present experiment. You can see these are two different jobs which we have to perform today using simulator software. This one is our raw material and this is our required workpiece. You can see the dimension of raw material is 100 mm by 40 mm. Now here the dia is 40 mm. We have to reduce it up to 20 mm. Now the total length is 100 mm. Again the 20 mm length will be clamped in the chuck like we did in the previous job of facing machine, facing operation, and up to 70 mm we will reduce this dia from 40 mm to 20 mm. You see here dia is 40 mm and here dia is 20 mm. Up to 70 mm length we have to reduce it up to 20 mm. So 70 mm length will be reduced to 20 mm dia. 20 mm length will be in the chuck of the lathe machine. This is the experiment which we will perform today on CNC simulator software with the help of G and M codes, which we have discussed earlier in the last lecture too. Now starting with the CNC simulator, first you will open the CNC simulator software. Then you will click on the top right side on the icon File Manager. Then this window will appear. Now there are three options you can see. The open project is option used to continue work from previous session. I mean, if you have already a job saved, you can open it from this option. The save is for saving the current progress, and new project is for starting new job, as we are doing here for facing operation. So we will start with the new project option. After starting the new project, you will set now the workpiece parameters. For this, you will click this icon here, second right top side. This window will appear. Now this is the workpiece length. This is the initial length of our raw material, which I have set 100 mm. This is the workpiece diameter, which is the initial diameter of our raw material, which is in this case 40 mm. This is the clamp length. Clamp length is the length inside this chuck. Here you can say the length of the raw material inside this chuck is known as the clamp length, which I have set 20 mm for good clamping. We have set all the initial parameters of our raw material: 100 mm length, 40 mm diameter. All these are the initial parameters of our raw material before facing operation. After setting the workpiece parameters, now you have to select the tool parameters. For this, you will click this third icon in the figure. This is for the tool selection. When you click this icon, this window will appear. Here you can see you have different options for tools. For turning, facing, there are different tools. Now in this case, we will select this 5 number tool, which is for journal, turning and facing. For selecting the tool, you have to drag the tool like in this way. From here you drag the tool this like and put it there. By doing this, you have selected now the 5 number tool, which is for journal, turning and facing. We have no need to change these parameters of the tool. You can see that there are options for selecting other tools like 2, 3, 4, 5. These are used for selecting multiple tools. Like you have studied that in tool pose, multiple tools can be adjusted at one time. So this option is used for selecting multiple tool selection. Now before starting the coding, I will summarize up till now what we have done. First, we have opened the CNC simulator. Then we have opened the new project. Then from here, we have set the workpiece parameters, this option. Then from here, we have selected the tool. I think I missed this highlighting option in the previous slide. So this is the third option for selecting the tool. Now the fourth option, this is used for the coding. You have to, when you will click this icon, a new window will appear like this. I have written the code, but when you will click this icon, there will appear a new blank window. Okay, then you have to write the code for the facing operation, or what operation you have to do. I have explained this coding in the later slides, but here I will tell you for every code there are three parts: the first part, the middle part and the end part. This is the first part of the program, like the from here this line to this line. This is the first part. This is the middle part from this line to the this line, and this is the end part from this line to this line. The first part of the program is generally used for switching options, like which units you are going to use, metric or inches, similarly to switch on the coolant. While the middle part is related with the workpiece details. You will define workpiece here like its length, diameter, which option you have to perform. All these details will be written here. In the end part, you will now close the program and other things like if the coolant is on, you will write the command here for switching off the coolant. Similarly, M30 is used like this line, it is used to close the program. For writing the program, you can use your own keyboard, and also the simulator on option for writing can be used, which I have discussed in detail in the coming slides. This is the keyboard of CNC simulator software I was talking about in the previous slide. This is the icon in the bottom taskbar. By clicking this icon in the bottom taskbar of the CNC simulator software where the writing code option is, this keyboard will appear. You can see this keyboard covers almost all the required alphabets, and all numbers are present in the keyboard. Also, other necessary buttons like enter, delete and backspace is also present. Here brackets are also present. So you can see you can use this virtual keyboard of CNC simulator, or if you don't want to use this, you can use your own laptop or a computer keyboard. It's up to you which keyboard you want to use for your own comfort. This is the code we will be using today for turning operation. Here you see many codes are same, used for facing operation the first experiment. So I have added the description from the previous slide. These are general codes like for coolant on off, setting spindle speed or selecting unit system. They will remain same for every task. So it is better if you memorize them. I will advise, they will help you. However, I will explain the new code here used for turning operation. Now starting with the code explanation, I will start with the very first line, which was 0001. This line is the start with the code O, and it O 0001. While writing a program on unicontroller, first line has to be start with O letter. It will always followed by a four-digit number. The number specifies from 0001 to 9999. I mean, this is the range of the its or code. Whenever you write a program, it always have to be specified by specific number. So in the very first line, we will specify our program code by giving it a specific number. Now moving towards the next line, this is the N10, G21, G99, G40. Starting with the N10 line, whenever N code is used, it is used to define the name or title of block of G code. Or simply, it defines the line number. So N10 means N line number 10. The next is G21. G21 code is used to switch between the metric system of units. So when we have used G21 code, so every dimension written in the code will be considered in millimeters. It is used for metric units in millimeters. G99 code G99 code select the units of the feed rate. So whenever in the code you have given the feed rate, it will consider it in millimeter per revolution. So we can say that we have now set our units in millimeter and we have set our feed rate in millimeter per revolution. Every value you give in the code, the length of your dimension will be in millimeters and the feed rate will be taken automatically in millimeter per revolution with the help of G21 and G99 code. G40 code is used for tool radius compensation. There are two other codes, G41 and G42, for left and right tool radius compensation. But here, with the help of G40, we are selecting automatic tool radius compensation. Now the machine will our CNC will automatically select the tool radius compensation according to the our tool and workpiece. Now discussing about G00 code. This code is used for the rapid G00 code is used for rapid positioning of tool. For example, if the tool is away from the workpiece, by using the G00 code, the tool will rapidly position towards the workpiece. This is the purpose of G00 code. G28 code. G28 code is used to move the tool to a reference point. Initially, we will set a reference point for the tool. So when we use a G28 code, after the work is finished, the tool will move to its reference point, which we have set earlier. U0 and W0, these are the secondary movements about Z and Y axis. These are used to move the tool in the X and Y axis according to our positioning. Now starting with the next command, this was T0101. Normally T command is used for changing of tool. As we have discussed earlier, there are a number of tools, almost 4 tools can be applied at different tool posts. So T command is used for changing of tool. Here the first two digits 01, it represents the tool number 1, and the second 01, this number represents the offset number. It means we have tool number 1 at one position. I am calling my tool which I have number in number 1 position to offset number 1 for the facing operation. So whenever T command is used, it is used for changing of tool. It can be 01, 02, 02, 01. Different tools at different numbers. Always remember the tool position for recalling the specific tool for specific operation. Like I have installed my tool at first position in the earlier slides, so I am recalling it from the first position. The next line is G96. G96 is used to rotate the spindle at constant RPM. So here you see the next code is S500. Both commands together means now the spindle will rotate constantly with the RPM of 500 revolution per minute. The rotation unit revolution per minute was selected in the previous slides. The next is M03. M03 is used for selecting clockwise rotation. Its opposite is M04, which when applied the spindle will rotate in anti-clockwise direction. Now X42 and Z2, this command is new here. For explaining the command, I have to draw the workpiece. So let me draw the workpiece. Uh, let's suppose this is your workpiece and this is x-axis perpendicular to the workpiece, and this is the z-axis. So X42 and Z42, these are used to give the initial points to the tool. As you remember, our diameter was 40. So let me write, our diameter was 40 and the length of our workpiece was 100 mm, and this length was 100 mm. So by X42 and Z2, what will happen? Our tool will move 2 millimeter away from the workpiece in X direction and 2 meter away from the workpiece in Z direction. Let's suppose this is our tool. Here, this is the point. This is the point. There will be 2 mm clearance in both axes. From Z axis, it will be 2 mm away from the tool, and from X axis, it will be 2 mm away from the workpiece. Our tool will be, this is gap is 2 mm. So by giving that command of X42 and Z2, our tool will move just to this point 2 mm away from the workpiece. When we start cutting, it will then cut the tool in both direction, because our workpiece will be rotating, and with the movement of tool it will be cut in both direction, in circular direction uniformly. Now G90 command. This command is used for turning cycle. This cycle is used to for stock removal in parallel tool path. For explaining this, let me draw the workpiece. Now suppose this is your workpiece and this is your tool. Now parallel tool path means for reducing the dia, your tool will move in this direction and along the z axis. Remember the axis I have drawn. This one was your z axis and this one was your x-axis. Now what will happen with the help of using G90 command? There are four options. Four different steps are going to be performed in G90 cycle. Rapid to X position. Rapid to X position, it will give the tool movement in X direction, in this direction. In the last slide I said the X direction was perpendicular to workpiece. Basically X and Z are perpendicular to each other. I have been mistaken in the last slide. So X and Z are perpendicular to each other. Rapid to X motion, this will give the tool motion in this direction. And feed to Z position, feed will give the movement to the tool in this direction. So first our tool will move into the workpiece for cutting, and with the help of Z feed it will move in this direction. Similarly, feed to start X position, when our required cut is finished, tool will move back to the initial position, and rapid to start Z position, then it will again move into the workpiece, and this cycle continues. I will explain the cycle in the next slide. This is our turning cycle. These four commands are explained in the next slide too. Here's the cycle line, the four distant moves with one line of information. These are the four distant moves which are explained in the next slide too. Now these are the four commands, 1, 2, 3, 4, which I am going to explain. Uh, Let me again draw the workpiece. Let's suppose this is our workpiece. Uh, this one is our z-axis. This one is our x-axis, and let's say this is our tool. So initially, what will happen? Remember, our dia was 40 mm. This whole dia was 40 mm. Let me write it here. This is 40 mm dia, and the whole length was 100 mm. And the whole length was 100 mm. But we have discussed in the initial slide, we will reduce dia from 40 to 20 mm. Let assume this middle line is 20 mm. Let me draw the new line. Let's say this is 20 mm line. This is 20 mm, and we have discussed we will reduce the diameter to 20 mm up to 70 mm length. The whole length is 100 mm, and let's say this point is 70 mm. So what we are going to do in this cycle, the first X35Z70 X35. Now the tool will move into the workpiece up to 35 mm. Let's say about up to this point. This is 35 mm. Tool will move from this point to this point, and it will cut up to 70 mm. This is X35 and Z70. Now what we have done, the tool have reduced its 5 mm dia. The dia from 40 mm it comes to 35 mm up to 70 mm length. Next is X25 mm. For X25 mm, this will happen from this point. Let's say this is up to 25 mm. This green line. Now what happened from 35? It comes to, oh sorry, 30 mm. This is 30 mm. Let me write it. This is 30 mm. From 35 it now comes to 30 mm up to 70 mm, and so again after 30 mm it will then come to 25 mm. This is 25 mm red one. Now again 25 mm up to 70 mm length. So these four cycles are continuously repeating. First move into the workpiece, then along z axis, then come back, then move into the workpiece, then along z axis. So in the fourth step we will reduce the dia from 40 mm to 20 mm along 70 mm length. Now at the end what will happen, our whole this part will come about dia of 20 mm. This all part will be cut off. Our workpiece will be of now 20 mm in diameter up to 70 mm length. Now after X35 and Z70, this F05 0.5, this is the feed rate, and M08, this is for coolant on. So let me summarize. With the help of turning cycle, this whole cycle and its four operations, we have reduced the dia up to 20 mm length. The initial length was 40 mm, we reduced it to 20 mm along 70 mm length up to this point. Okay, we have done the turning in four different steps, not in the one single step as discussed in the last lecture. This is for safety of tool, otherwise tool will get heat up. If there is still any ambiguity, you can watch each step separately discussed in the video in the last slide. So in this lecture also, in the last slide there is a video which you can see, which have clear pictures for better understanding of each and every step. Now coming to the end of the program, as discussed earlier, there are three parts of program. First part was the initialization, which we have set, then the middle part in which we have written all the code including G94, now the end of the program. At the end of the program, the first one is G00. G00 gives the rapid linear into position to the tool, means it moves the tool away from the workpiece to a specified position rapidly. Z10, it is similar, the tool will move 10 mm away from the workpiece in the positive Z direction, means it again moving the tool away from the workpiece. And M09 is used for turning the coolant off. In the previous slide we have used M08 in which we have turned the coolant on. Now in M09 we have turned the coolant off. G28, if by chance if you have not used G00, and then G28 reference point returns the tool first to G00 position. This is often known as intermediate position to which tool is returned. Then after G00, it will go back to the home position. Here reference points U, W, these are along about X and Z axis. I have selected both 0, 0. So the tool will now return to X0 and Y0. At the end there is M30. M30 is used for the completion of the control program. It is always used at the end of the program. Now here our program is complete at M30. So far your coding is complete, your program is complete. Now we have to run the simulation for checking if any error is there, we can notify. Uh, there is a play button. From here you can run the simulation. So if there is any error, it will be notified. As discussed earlier, before working, we will run the simulation for checking the error. Here is the pause and stop button. If you want to pause or stop the program, you can use these buttons. And this bookmark icon, this is used if you have any confusion regarding any code, then click this icon. The detail for every code will be available to you for checking of any code or any other information regarding the code. Up till now, your work is complete, your code is complete, simulation has been done. So now we have to save the project. Again, click the topmost icon in the right side. By clicking this icon, this window will appear. Here you will click the save project. By clicking this option, you will save the current all progress. Remember that don't use space in between the alphabets. Always use underscore sign because the space sign will not be read by the software. So use underscore sign in between the alphabets if you have to use them. Also, in the next slide, there is complete video for the program written along with running simulation. Each step is described live one by one for better understanding. So if you have any confusion so far, please see the video in the next slide recorded in Urdu. A video will give you the detail of every step with running simulation. And thank you.
प्लेन टर्निंग को परफॉर्म करने के लिए बेसिकली ये पूरी एक वीडियो बनाई गई है। सबसे पहले फ़ाइल मैनेजर में आप जाएंगे, फ़ाइल मैनेजर में आप न्यू प्रोजेक्ट पे क्लिक करेंगे और ओके करेंगे। उसके बाद आप जाएंगे वर्क पीस के पैरामीटर्स पे। वर्क पीस के पैरामीटर को एडजस्ट करने के लिए सबसे पहले आपने वर्क पीस के डायमीटर को देखना है। तो वर्क पीस का डायमीटर हमने 40 mm रखना है, जो कि 3 चक में ये आपके सामने वर्क पीस प्लेस है। उसके बाद क्लैंप लेंथ, बेसिकली वो लेंथ होती है जो कि 3 चक के अंदर आप इसको एडजस्ट करते हैं, जो हमने 20 mm रखनी है। और एंड अलाउंस, बेसिकली ये वर्क पीस के कोऑर्डिनेट्स होते हैं जो हमने ज़ीरो रखे हैं, कि वर्क पीस के जो यहाँ से स्टार्टिंग पॉइंट है वहाँ और उसके एंड अलाउंस ज़ीरो है। अब हम आ जाते हैं टूल के पैरामीटर्स में। ये बेसिकली टूल कैटलॉग्स हैं जिसमें मुख्तलिफ हमारे पास टूल्स आपको इसमें नज़र आ रहे हैं। तो हमने फेसिंग एंड टर्निंग टूल को सिलेक्ट करना है, इसको क्लिक करके ड्रैग करके आपने पोजीशन नंबर 1 पर लेके जाना है। इसमें चेंजिंग की करने की कोई ज़रूरत नहीं है, आप जस्ट आगे कोड एडिटर पे क्लिक करेंगे। कोड एडिटर में आपके सामने जो है ये इसका मैनुअल कीबोर्ड, आप इसको मैनुअल इंटर भी कर सकते हैं और अपने लैपटॉप के कीबोर्ड से भी इंटर कर सकते हैं। जस्ट मैं इसको आप पेस्ट करूँगा और पूरे प्रोग्राम को, और आप इसको राइट अप कर सकते हैं। इसके बाद मैं अब डिफरेंट कैमरा की लोकेशन से अपने वर्क पीस और टूल को देख रहा हूँ। ये बेसिकली हमारा टूल है, ये हमारा वर्क पीस है जो कि क्लैंप है 3 चक में। अब इसके बाद हम एक और इसका कैमरे का व्यू लेंगे और इस हमने जो है सिमुलेशंस को ऑन करने से पहले हम इसके एक एक्सटेंडेड व्यू जो है वो देख रहे हैं। अब जब हम सिमुलेशंस को ऑन करेंगे तो बेसिकली ये हमारा कूलेंट ऑन होगा, ये 3 चक हमारा चल पड़ा है और ये हमारा टूल की जो है वो मूवमेंट हो रही है। बेसिकली फर्स्ट स्टेप में हम 5 mm का जो डेप्थ ऑफ कट है वो हमने दी है, तो वो 5 mm इसका जो डाया है उसको रिड्यूस कर रहा है और स्पेसिफाइड लेंथ जो हमने Z70 का दिया था तो 70 mm तक की लेंथ तक उसको वो काटेगा। तो बेसिकली ये आपको नज़र आ रहा है कि ये टूल्स जब वर्क पीस को काटा तो उसकी चिप्स जो हैं वो रिमूव हो रही हैं और कूलेंट्स ऑन है। 3 चक जो है वो वर्क पीस को मुसलसल जो है वो मूव करवा रहा है। तो ये आपको इसके सबसे ज़्यादा जो अहम चीज़ ये है कि आपको टूल जो है वो टूल पाथ जो है उसको फॉलो करते हुए नज़र आ रहा होगा। ये ग्रीन लाइन जो है ये टूल पाथ को शो कर रही हैं। तो अब ये दोबारा 5 mm डेप्थ ऑफ कट का एक और जो है ये वो आप 2D डायग्राम जो कैमरा है उसमें आप देख सकते हैं। और ये जो है हमारा फाइनल जो है वर्क पीस जो है उसकी जो फाइनल वर्क पीस की जो लुक होगी वो कुछ इस तरह की होगी। अब हमारा प्रोग्राम बिल्कुल एंड हो चुका है, आपको साथ साथ इसके प्रोग्राम नज़र आ रहा था। अब आपके जो डिज़ायर्ड शेप थी वो कंप्लीट हो चुकी है। अब हम इसके डिफरेंट जो है वो कैमरा की लोकेशन देख सकते हैं। ये 2D जो फाइनल हमारा जो वर्क पीस था रिक्वायर्ड वो इस शेप में था। हमने इसके 40 mm के डाया को कम करके 20 mm कर दिया। ये हमारी CNC की मशीन है, लेथ मशीन, जो कि हमारी वर्कशॉप लैब में अवेलेबल है। तो हमारा क्योंकि ये कोड पूरा इस पर कंप्लीट रन हो चुका है, अब हम इसको फर्दर जो है आगे एक्चुअल लेथ मशीन पे इसको हम चला सकते हैं, CNC लेथ मशीन पे।